This is Tanbridge House School in Horsham. The maths department here has embarked on a project to improve their teaching and to make maths more stimulating for their pupils by making better use of ICT. They're being helped by Alison Clark-Jevons of the Mathematics Centre at University College Chichester. Today, she's introducing the staff to some new applications, like this fully functioning graphical whiteboard calculator.
Here, not only can the pupils see the screen, but they can also see which buttons you're pressing, and if it's a really complicated
Alison also
sequence,
shows them an interactive number line that they can use with their pupils to explore numbers and the relationships between them.
This time, and this is where if I was in the classroom, I wouldn't be operating this. I'd be asking one of the pupils or one of you to come up and see what happens.
As they experiment with the new software, the teachers discuss the impact it might have on their teaching.
Yeah, and then I'd get a student up.
I was going to say, would you get them up to click it on?
And then they press the on button and show the true value.
Yeah, I think that'd be nice.
They're not sitting waiting while you're writing. They're with it all the time, and the lesson you should get much more covered, and hopefully they would learn a lot more.
It gives you the opportunity to be able to think of more questions, so it might mean us going having a departmental meeting where we can actually think of lots of questions that go with various sort of levels of students.
So straight away, maths teacher Barry Miles tries out the new interactive number line for the first time with his class of middle ability Year 7 pupils.
Okay. Thank you very much. And what would you hazard a guess at there for?
10.7.
10.7? Let's see what it actually is. 10.7.
The purpose of the lesson is to look at expressions involving the letter n, including some which are often the source of confusion, such as 2n and n squared.
But here we can actually see it's totally
In the plenary session, they discuss these expressions.
When might n squared be the same as 2n?
2.
2. You want to have a quick try? Your answer, you show it. Looking for any places where they may have the same answer, although they're not equivalent. On 2, look at that. One under the other, yeah, because 2 times 2 is 4, and that is 2 squared, isn't it? Anywhere else that it might be the same.
Barry realises he can involve the pupils more by letting them explore the number relationships for themselves on the number line, leaving him to ask more questions.
So that way, what's happening to A when you go move to the right? Yeah.
It's going 10 more than it should.
Well, it's going a lot further, isn't it? You're losing off the scale. So going that way, you would expect A to go further and further away from you, wouldn't you? We'll try it the other way then. It's coming back, it's getting closer. That's the one we had. Yeah, keep going. Because A is under there, but look at that, on 0. The package is quite easy to use, and the children can find out how to use it quite easily themselves. So from my point of view, it's revising my questioning techniques so that I can actually sort of get the misconceptions out of them, and hopefully it just breed their interest in the whole maths concepts.
We're going to use a bit of equipment today that you haven't seen before, and I've only used once, so we're going to see whether it goes well or not, okay? And I'm just going to start straight away by asking for a volunteer who's going to come and see what happens when we use it. Go on, Ian.
Later the same day, Jenna Matthews is using this data plotter for the first time with her lower ability Year 8
What
group.
I need you to do is stand right there. Brilliant. Right. Give me 2 seconds to switch it on. Oh. Okay, right. What I'd like you to do, Ian, is move towards me, please.
When a pupil moves
now
towards
I'd
or
like to
away
move
from the
away
plotter,
from me.
it automatically draws a time and distance graph.
Okay.
Then the pupils get to work on some ready-made time and distance graphs, trying to work out what they represent.
3 seconds.
Moving towards.
That's moving towards. You're upside down.
It's here. The range is here.
Then stand still.
Waist. That's a quickly.
On your marks. Get set.
The new and more risky element of the lesson is when Jenna gets her normally boisterous pupils to try and create a time and distance plot of their movements that matches the printed graph.
Nice, you spitting in.
That's good, Andy. That's really good. Okay, so the bit that we're still not getting then is the standing still for long enough. Okay, Amber, your turn.
I've seen this type of activity used with pupils from year 4 to year 9, and in every case there's been significant learning taking place as a direct result of the pupils watching the different graphs appear on the screen and really correcting and using that ICT, the feedback that they're getting from that, to be able to correct and modify what they're doing.
Everybody does that.
And really challenging the concepts that they've got about distance time graphs.
Go forwards. Stand still. Forwards. Go forwards.
Nearly. Very nearly. Good. That is the best so far. Okay, well done. Fraser, what have we learned today?
It's going up, then you're moving away. If it's straight line, then you're standing still. If it's moving towards the line, it's going towards the ranger.
Excellent. Okay.
Okay, so what is going to be my...
Gemma Woolley is introducing her lower ability year 9s to rotational symmetry.
3, 4, 5. Lovely. How much am I having to turn this square round?
90.
90, brilliant. Okay, and then we've got, what shape was this called again?
Pentagon.
Pentagon. Okay, so now I've got to do 360 divided by 5. What's 360
It's hard
divided
going
by 5?
on a warm afternoon. But things brighten up when Gemma takes the class to the ICT suite, where she lets them loose on some interactive geometry software the school has recently installed. Using this, the pupils can create their own shapes, duplicate them, and rotate them to explore what order of symmetry they possess.
What's really interesting about the way the pupils are working here is that they're actually given the opportunity to create something, and in doing so they're really testing their ideas out and using the software to help them to see what's going on. So they'll be learning about what would be good numbers to choose in order to get a shape which has got an order of rotational symmetry that makes sense to them.
Go on one that has a Z on it, and go to this triangle. Keep on rotates and go as a box and rotate it.
You're going to go for 50, right?
Rotate it. Rotate it.
I don't know how to colour it, I just don't know how to change the colour.
What the teacher will get from this situation is a context to be able to go back into the classroom next lesson and talk about, you know, how important the numbers that worked or gave nice symmetrical patterns were, and how they relate to 360 degrees.
When I brought them into the computer suite last week and then practiced on the whiteboard, the things that they were remembering I was absolutely amazed about, and if I'd done that in the classroom I don't think they would have.
So the first thing that I'm going to start with is I'm going to ask you to draw a square.
Head of Maths Geraldine Garley is using the latest graphical calculators with her higher set Year 10s. She's also using the new interactive whiteboard calculator to demonstrate what they should do.
I've got 2 equations. So let's clear. Now I'd like to see you draw a square in this orientation. They are all going to be in the format y equals mx plus c.
The pupils already know how to plot straight line graphs, but Geraldine wants them to explore and discuss amongst themselves how to solve this problem by plotting 4 lines that intersect to make a square.
There we go.
Yeah, there you go.
I think a good place to go next would be to think about if it was slightly tilted even more.
If I change the orientation,
Yes.
they might be able to give me the equation of one of the sides.
Yes.
Yeah?
Yes.
Go for that. Okay. Right, the students, if I can just pull you together. What I'd like you to do now is tilt it even more. Perhaps something like that.
That's a bit better.
Minus 0.5.
So what does that changing those?
The minuses.
Creating this square isn't so easy.
So like you now know how to get those lines. 2 lines in, or you can move that one up or that one down. Go on.
And then you can't get. It won't be. That's not a square though, is it? It's not a right angle. Minus 2x. Yeah.
How do the pupils react to this different approach to teaching and learning?
It's just more about exploring, I think, whereas normally we just taught the facts, I think. So, yeah, it's more about investigating.
Yeah, I feel it's much more relaxed because this guy is just letting us investigate on our own. She's not like lecturing us about it or anything. So I think it's better.
It's slightly different because normally we work out of exercise books and we normally work in our orange books, which we've got all our work in.
Because the interactive whiteboards have only just been reinstalled, it helps that we can see the calculator display on the big whiteboard. So we can see what she does and easily replicate it, whereas if she's just talking about it, it's more difficult.
Geraldine then gets pupils up to the whiteboard to show their workings.
Right, so we've changed the side to 3x plus 2.
Yeah, that's all right.
Has Simon drawn his square? Yeah, he's done pretty good. I think he gets a...
I think Geraldine really did maximise the use of the Smart View software in this lesson because what we saw were beautiful examples of pupils coming up to the board, sharing their ideas and actually helping each other. If, even if a wrong button was pressed, you got the feeling that they were supporting each other with what was going on the board, which I think is a really important aspect of any mathematics classroom. Other nice things that I noticed were the pupils had their own calculators, so they could very much work independently and quite privately with what they were doing, but then when they were ready to share their ideas with others in their group, Geraldine had actually structured the task around a paired or group activity, so they could have a little experiment and then come back together and begin to formalise some of the aspects of the maths that Geraldine was trying to draw out there.
It's one of the lovely things of handheld technology is I can try, I can hold it, and I actually don't have to show it to anybody until I'm right. So graphic calculators is something that I've introduced into improving how we teach and how the pupils learn somewhat difficult concepts.
And how are Geraldine's maths colleagues taking to the introduction of the new technology?
Initially with the teachers, there's that fear of, I don't want to show myself up in front of the pupils that I don't know. And we've had to work really hard on that because what they don't know is a skill. They know the knowledge. And the very confident teachers, once we give them the skills, they are delivering wonderful lessons.